Okay, moving on. If you want to simplify some radicals, what you do need to know is that when you're taking the square root of a negative, it is now possible to simplify it, because remember that you can separate out the square root of -1 as part of your whole process. So for example, if I take out the negative part by taking out the square root of -1, I can then say that the square root of 27, working with it in a positive way, would be the same as the square root of 9 times the square root of 3. So you see how the negative is in its own part now, and then 9 times 3, -1 times 9 times 3 is -27. And again, we can do the same thing with the square root of a -48. We can separate the square root of -1 as a separate entity, and then the square root of 48, we can separate that into the square root of 16 times the square root of 3. So the square root of -1 is the letter I. Square root of 9 is 3, and the square root of 3 stays the same. Over here, the square root of 16 is 4, and the square root of 3 stays the same. Now, if we want to add these two together, I'm just going to put them in the normal order that we place these. And that would be that the 3 comes first, the I comes second, and then the square root of 3 comes last. The reason why the square root comes last is that we always worry about making the bar too long. So if we put it last, we know exactly what it's covering, because that's always just the last term. Anyway, these two are like terms, 3i root 3 and 4i root 3, because they're both I terms and they both have a root 3 in them. So I can add them together to make 7i root 3. Remember, the way that you can tell that something are like terms is that everything after the constant has to match. So everything after the 3 and after the 4 has to match. So I root 3, yep, everything after those first constant terms matches. So they're like terms. The last two examples, here if I have something squared, I want to simplify inside first. Simplify your radicals first. It's really going to save you a lot of work down the road, so please do that first. The square root of -3 is the same as the square root of 3 times the square root of -1, which is just root 3 times I, or the other way around, I root 3. So that is the same as -2 plus I root 3. Okay, now I can start focusing on the question as a whole. Basically, I have a binomial squared. When you square something, you're just multiplying that thing times itself. And as you can see, I have a binomial times a binomial, so I'm going to FOIL these out. Foiling them gets me first, outer, inner, last, so I have 4, these are like terms, minus 4i root 3, plus, I squared, that's -1. So I have 4 minus 4i root 3 minus 3. 4 take away 3 is 1. So my final answer is 1 minus 4i root 3. Now, finally, the last one is actually not that tricky. Again, we're going to simplify our radical first. That would be that one right there. So I'm going to rewrite that part as the square root of -1 times the square root of 4 times the square root of 3. I'm breaking out the negative, and I'm also separating the square root of 12 into root 4 root 3. So I get I, and then the square root of 4 is a 2, and then root 3. Now normally we don't write it in that order. We would write it like this instead, with the 2 first, and then the I, and then the root. Okay. Again, this is another opportunity for us to consolidate this fraction, break it apart, and simplify it as two separate fractions. We have to do this now because complex numbers are in two separate forms, the A part and the B part, the I part, not one big glob like this. So our last basic step is to separate this into two separate fractions. You can see the first part becomes -7 when you divide them, and the second part, the 2's are going to cancel, and you get I root 3.